A pendulum has a period of 3 seconds as measured in its inertial frame of reference. An observer is moving with a speed of 0.8 c with respect to the pendulum's frame. What is the period of the pendulum measured by the observer? So there is a reference frame in which pendulum is stationary, and there is another reference frame with the observer. And it may be that this reference frame with the observer is moving, but situation is symmetrical. It may be that this reference frame is stationary, but this is moving. It doesn't matter. And what is proper time interval? By definition, it's a time interval measured in the reference frame where two events happen at the same point. And in the pendulum's frame, a ball is somewhere here, and it does one oscillation, and it's again at the same point. So time interval measured in the pendulum's frame, it's a proper time interval. So these 3 seconds, it's a proper time interval, and a moving observer moving relative to this pendulum's reference frame, because when this reference frame is stationary but this is moving with respect to this pendulum, it seems that the observer is moving in opposite direction. This situation is symmetrical. So this observer will measure dilated time interval. It means a greater time interval, and it's greater by factor of gamma, which is 1 over square root of 1 minus v squared over c squared. And how to remember? For example, there is a stationary observer on the Earth, and there is a moving rocket, and something happens in the rocket. So since, for example, the same pendulum, so with respect to the rocket's reference frame, it's a proper time interval, because a ball is at the same point, or time is measured when a ball is at the same point. And this observer on the Earth will watch slow motion and will measure dilated time interval. And it may be that a rocket is moving, and the situation is symmetrical. It may be that a rocket is stationary, but this reference frame is moving, the observer is moving. Anyway, pendulum is stationary with respect to the rocket's reference frame, so time interval with respect to the rocket's reference frame, it's a proper time interval. So gamma is 1 over square root of 1 minus 0.8 squared is 0.64, and it's 0.36, and square root it's 0.6. And it's 6 over 10. You may use a calculator. It's 10 over 6 or 5 over 3, and hence dilated time interval, it's 3 times 5 over 3, it's 5 seconds. So it's B. And that's all for this question.